Alright guys, Jay at Broader Performance here. I'm going to try to explain what converter lockup is on an automatic transmission and how it works. Some people don't really know what that means. When you say, do you want a lockup converter or do you have a lockup converter? A lot of people don't even understand what that means. So let's go over that a little bit and hydraulically and mechanically how a lockup converter works as well. Now there's different designs. I'm going to go with the most popular design here. This example in particular is a Ford 4R70W, but this is pretty typical of most transmissions. There are some exceptions out there, but this is going to be most often how they work. So let's go over the components here. So this is a torque converter taken apart, basically. So this is what's called the cover, and this is the side that bolts to the flex plate. This is the lockup disc. This is called the turbine, or some call it a turbine, which I don't know which is correct. To me, a turbine is something you wear on your head. I don't typically wear these on my head, but I don't know, might be kind of cool. Maybe I'll give that a try someday. This they're calling a reactor. A lot of people call it a stator. Either way is correct, I'm sure. This here is called the impeller. Also can be called the pump. Okay, so these are the components. Now, what lockup does is, if you don't know what lockup even is, so basically a torque converter never couples 100%. It's always got some slippage to it. So in the quest for better gas mileage as the years rolled on, I guess they started doing this. I don't know exactly when. I'm going to say roughly 1980, let's say. Maybe some of you guys know when a lockup converter first came out. I'm not really sure, and they may have had something way back on some of these old antique units, but it became popular, say, roughly 1980, okay? And it was, the idea of it is for better gas mileage. It also makes the transmission run cooler because when the converter slips, it generates heat. So when you remove the slippage from the converter by locking it up, you don't have that heat build up from the converter anymore. So temperatures in the transmission go down. So, okay, what is lockup? What does that mean? Well, if we look at the turbine here, if you kind of look here, this is a set of splines in here. And the input shaft of the transmission splines into this. Your lockup disc splines into this turbine, or turbine, whatever you want to call it. The cover, which is bolted directly to the flywheel, or flex plate rather, this has a surface on it, and this typically has a clutch, okay? This has like a friction material. Sometimes it's actually on the cover, sometimes it's on the damper itself here, or I'm sorry, the lockup disc. And what happens is this gets pressed up against the cover hydraulically because this is tied into the turbine and the turbine is tied into the input shaft. We've essentially bypassed what they're calling here the reactor or the stator and the impeller or the pump, whichever you want to call it. These are the things that allow the torque converter to stall and make it also makes a hydraulic gear reducer, which is kind of hard to explain, but it doesn't really turn 1 to 1. Especially under stall conditions, it might have a gear ratio of, say, roughly 2 to 1 or 1.5 to 1 or anywhere in between. And, I know that gets a little confusing, and that's something we can go over in another video. But so basically, when this is coupled with the cover, or forced up against it with the friction ring here, the input shaft just kind of bypasses everything. So the input shaft is basically directly coupled to the crankshaft, which is essentially what's happening. Okay, so that's lockup. So how does this work? Well, this isn't a great diagram, but essentially what's happening here, so when the converter is released, oil comes down the center of the input shaft, and if you can tell here, I know it's a little tough with this diagram, but this is a cutaway version of the cover, and this, what you're seeing here, this is the converter clutch, okay? And again, that's splined into this piece here, which is your turbine or your turbine. So what happens is the oil comes down through the center of the shaft. There's a seal on here, and the oil builds up pressure between the cover and the clutch disc, and it pushes this clutch disc away from the cover, and you get a coat of oil in here, and then it comes out through here, and then it exits through the oiling system of the transmission, which that's another video on where that oil goes. But basically I want you to think of it as this oil goes off and vents out, okay? So we get pressure build up here, which keeps this clutch disc from pushing up against the cover, and then we're letting the pressure in here be low. So we want high pressure here, and then we have low pressure here. So that pushes this disc in this direction and essentially releases it. Now, to apply it, what happens within the transmission, there's a valving system, could be in the pump, could be in the valve body, and what it does is it reverses the oil flow. It reverses the direction of oil flow. So now what happens, the oil, instead of venting out inside the converter, we're changing the pressure zone. So between the clutch disc and the cover, this oil goes to vent and vents out through the input shaft, the center of the input shaft. So now what's happened is we've got a low pressure here and we have a high pressure here. Okay, because the oil is coming in through here, filling the converter up, forcing this disc up against the cover, and because we've vented off in here, pressure is low, and this allows this to be hydraulically forced against the cover, so this will no longer spin because there's a friction disc here. Okay, just like a clutch pack. It's just a big single clutch. That's in this one. You know, there are ones with multiple clutch discs and all that. Again, probably another topic there, but it doesn't really matter whether it's a single disc or has another plate in between. So basically pressure in here, low pressure here, that forces this into lockup mode. And the diameter of this disc, by making the diameter of this disc bigger, increasing surface area, increases this hydraulic pressure, because you have more surface area. You always remember the term pounds per square inch. So the bigger the piston is, or more square inches it has, the more force it is up against the cover. And that gives you more holding power. On some of these racing converters where the diameter gets smaller, you have a smaller piston, less PSI, less holding power. So that's something, getting a little bit off topic here, but and maybe I shouldn't go down that road. So let's not discuss that. But so anyways, this is how this hydraulically works. Again, you're reversing the direction of oil flow. So basically, high pressure zone, low pressure zone to release this clutch. And then you reverse the valve, you reverse the direction of the oil flow. and then you create low pressure in here and high pressure within the converter. And of course, increasing this pressure will increase this holding power on this clutch. And then again, that's kind of getting into concepts we don't really need to talk about right now. I'm kind of getting ahead of myself here, but in any case, that's how most of these work. There are some exceptions. I only work on certain units. I'm not, there's probably 100 or more models of transmissions. I don't even know. When you go through all the foreign cars and all the year model changes, and there's an awful lot of transmissions in the world, so I don't know how they all work. I don't work on everything, but let's talk about a C5 transmission. Some of you guys are familiar with this. This was basically a newer version of a C4, and it had a lockup converter. And a lot of people think that, because a C5, if you're familiar with it, had an extra valve body added, like stacked on top of the regular valve body. And a lot of people thought that that was for the converter lockup. And it's actually not true. So I've got take a look here. I've got the Ford training manual here that shows you how this works. And if you look at this is the clutch disc. It's showing the friction pads on the outside. And if you look here, centrifugal clutch shoe. So what would happen is when this would get to a certain RPM, centrifugal force would actually engage this clutch. It didn't work very well because what would happen is you would get at a certain RPM too long, and the clutch would just be be slipping and really weak and really wearing on the friction material. So it was typical for these to be burned up pretty fast, pretty low miles. And Ford used to basically tell you when you rebuilt it, you would remove this piece, and they gave you this aluminum spacer that went here on the turbine, and then went to the cover, and then would just take up the space of this, so it would no longer lock up. They just had to get rid of it because this kind of design didn't work. Now, an AOD is another transmission that does not work like the first, like this 470W or, let's say more conventional way. That did not have a traditional clutch inside the converter. And I don't know where my training manual is on that. I'll make another video out of the AOD. It's a little bit more complex than this C5 deal here. And I'll show that in another video on how the AOD lockup works. There's a whole lot of things to discuss with an AOD. Because the strange thing about the AOD is eliminating the lockup in the converter really helps its power handling ability. And so there's a lot of things to discuss there. So I'm going to do that in a separate video at some point. But I hope this makes a little bit of sense to you. This is just another view of that C5. And you can see, centrifugal clutch shoe. And you can see that little clutch material here. And it's just like a shoe, and it hooks on, it grabs on the outside. Rather than the other one, it grabs on this flat surface here in the face. You have more surface area. But again, this didn't work very well. So Ford used to recommend to get rid of all that back in the day. So anyways, we'll do AOD in another one. I hope this makes a little bit of sense to you. And yeah, I guess that's all I can tell you about it. I can at some point maybe show you some live pieces of a converter, and we can look at it, and we can look at different designs, and maybe talk about aftermarket, multi-disc, modifications to the circuit to try to get the holding power better, and things like that. So we can cover this more in depth later on. But as far as basic operation, that's what it is, and that's how it works. And I hope it made some sense to you. Thanks for watching.